Hello everyone, welcome to my channel. I am still looking at integration, and in this video I'm going to be looking at a triple integral, as you can see, and I want to demonstrate to you that Fubini theorem also works even in the case of triple integral. So I'm gonna start by integrating with respect to x, and then I'll change the order of integration. I'll start with integration with respect to y first, and then I'm going to leave you to do the last part. Now we have a function here, x squared plus y squared plus z squared, and we're integrating over this region here from 0 up to 1 for all the integrals. And of course we have the first integral there, first limit corresponding to x, second limit as you move out corresponding to y, and then the last limits 0 up to 1 corresponding to z there. All right, so how do we go about this? Now here is the way we approach it. No difference in terms of techniques and approach. Let's go call this one page 1, and I have the integral from 0 up to 1, and then from 0 up to 1, and then from 0 up to 1 of x squared plus y squared plus z squared, and we're told this is dx, dy, and then dz. So like I told you, we are going to start with the inner integral, and here is the approach. So this is the integral from 0 up to 1, integral from 0 up to 1, and I'm going to use brackets here now, integral from 0 up to 1, and I'm going to say x squared plus y squared plus z squared, and then I'm going to say here dx, and then I'm going to close this one, this bracket closing there, and I have dy dz. Now we're integrating with respect to x, and therefore these must be treated as constants. So the integral of x squared is x cubed over 3. So this integral from 0 up to 1, integral from 0 up to 1. Inside there, I have x cubed over 3. And here, remember, is a constant. So integration with respect to x, you will have y squared x there. So this will be plus y squared x. And this will be z squared x. You know what I mean? Basically, I'm saying if you have the integral of y with respect to x like this, remember that will be a constant, you take it out, so this will be y, you have 1 here, dx. What is the integral of 1 with respect to x? Obviously it's x, so you are going to have yx. That's why we have y squared x there and z squared x there. Limits of integration we have to specify because we have many variables here. So we're going to say we're talking about x equal to 1 up 0 up to 1, from x equal to 0 up to x equals 1, and then we have dy dz outside there. Now let's do the cleaning up. This is the integral from 0 up to 1, and then the integral from 0 up to 1 of what? We're putting 1 there, and then 1 in that space and 1 in that space. Then we're going to put 0. So this is 1 cubed over 3 plus y squared times 1 plus z squared times 1. And then we're going to say minus. We're here putting 0 there, 0 cubed over 3 plus y times 0. This is y squared, and then plus z squared times 0. And then we have to close this, and then we have to close the a bigger bracket there, and then we have dy dz outside there. Remember that dy dz, you can see it there. Let's do the cleaning up. This is 0 up to 1, the integral of 0, the integral from 0 up to 1, another integral from 0 up to 1 of what? This will be 1/3 plus y squared plus z squared. This is 0, you can see there, and then we have dy dz. Now this time we have to integrate with respect to y, so this will be integral from 0 up to 1 of what? Let me use brackets there, and I'm going to talk about from 0 up to 1 of 1 over 3 plus y squared plus z squared, and then dy, and then let me close this bracket here, and then I'm going to have dz outside. Now this is a constant with respect to y, that's a constant, and that's a constant. Taking us to page 2, we're now having hope you can see there. Let me move down a little bit more. Right, so now I'm basically saying that integral, this set of this integral out works out as follows: 0 up to 1. Inside there, let me use that bracket there. Remember, we're integrating with respect to y. That's a constant, so that's just 1 over 3 y, and this will be plus y cubed over 3, and then plus z squared y. Remember that. Limits of integration were from 0 up to 1. I'm going to have to say y equals, because we have two variables there. We have z and y. So I'm going to have to say here y equals 0 up to y equals 1. I'm going to come and fix that, but let me just first of all write upper limit there, y equals 1. And we can close and say the z outside. I'll come and fix that. Now let's perform the substitution then. So this is going to be 0 up to 1. What are we having now? Putting 1 there, and there, and there, and then we'll take 0 at the end. So 1 over 3 times 1 plus 1 cubed over 3 plus z squared times 1, and then minus, putting 0 there, there, and there. So 1 over 3 times 0 plus 0 cubed over 3 plus z squared times 0, like that, and then the z outside. Let me fix this one before I forget. Y equals 0 out 1, y equals 1, like this. Now if you check, this is integral from 0 up to 1. This will be 1/3 1 over 3 plus 1 over 3 plus z squared, and then this is 0 all of it, and then we have the z outside. Now let's integrate this. Remember, this is 2/3, so this integral from 0 up to 1 of what? Of 2/3 plus z squared, and then the z. Let's integrate this. This is a constant, remember, so we're going to have the integral, actually, because now we need to perform the integral. Okay, let me distribute first. 2 over 3, and then the z, and then we're saying from 0 up to 1 plus the integral of z squared from 0 up to 1 dz. Now this, we can take the 2/3 out. 2 over 3 integral from 0 up to 1 of 1 dz, and then plus here integral of z squared is actually z power 3 over 3. Limits of integration 0 all the way up to 1. Let's work on this one. This is just 2/3 of z, limits of integration 0 up to 1. Let me do this. Plus here, put 1 there. You're gonna get, you can actually take 1 over 3 out, and then put 1 cubed minus 0 cubed, like that. Simplifying this part, is 2 over 3, and then we have z minus 0. Put 1 there, and then put 0 there, like that. And then what we have, this is basically 1 plus 1/3 is 1 over 3. Now let's check this. This is equal to, if you check this part here, this is 1 times 2/3 is 2/3 plus 1/3, and the answer is 3 over 3, which is equal to 1. So that's our final solution, 1. Now starting with x, integrating with respect to x, remember we started from here. This is our solution right there. We started with integration with respect to x, and then we ended up with respect to z. Now I want to change the order of integration. Start with y, and then x, you are going to look at starting with z, right? So we're looking at changing, remember our solution is 1. So changing the order of integration is my next step. What do we get? Changing the order, changing the order of integration, changing the order of integration we get, check now, here we go. I'm now going to take, as it were, this there and that one there, then this there, that one there, if you follow what I mean. So now I'm going to have the integral from 0 up to 1. Integral limits are the same here. That makes it easier for us. 0 up to 1. I'm going to keep the function exactly how it is, x squared plus y squared plus z squared. But now we're dealing with dy, dx, then dz. Right, now approach, same approach. This is z, remember. Same approach, so I'm going to say this is equal to integral from 0 up to 1, and then integral from 0 up to 1. Use brackets there. Integral from 0 up to 1, and let me use round brackets, x squared plus y squared plus z squared, and then I'm going to say here dy, and I'm going to close that bracket there, and then I have dx dz outside. Now, working on this, integrating with respect to y, that will be a constant and that will be a constant. So now I have, this is the same as integral from 0 up to 1, integral from 0 up to 1 of what? That one will be x squared y plus y cubed over 3 plus z squared y. Limits of integration, we're going to say y is equal to 0 all the way up to y equals 1. And then outside I have dx dz. Now simplifying, remember now here y is a x squared is a constant, there z is a constant. So now I have integral from 0 up to 1, integral from 0 up to 1 of, let me substitute. So I'm putting 1 there, so it will be x squared times 1 plus 1 cubed over 3, and then plus z squared times 1, and then I must say minus, watch this, put 0 there and there and there, so it will be x squared times 0 plus 0 cubed over 3 plus z squared times 0, and then I have to close that and then close that and then say dx dz. Now this is 0 obviously, as you can see. What is our next step? Integral from 0 up to 1, integral from 0 up to 1 of what? Of x squared here plus 1 over 3 plus z squared, and then we are talking about dx dz, right? Now our next integration is going to be with respect to x. That takes me to the next page. I have not numbered this one here, changing the order of integration. I haven't numbered it, so let me just keep it the way it is. So now we're saying this is the same as the integral from 0 up to 1. Now notice we're integrating this one now with respect to x. That will be a constant and that will be a constant. So now we are now saying that what we have now is x cubed over 3. I hope you can see what I'm writing. Let me move this one down, and I must maintain there. Okay, there you go. Yeah, you can see it there. And then I'm going to have plus 1/3 x plus z squared x. Limits of integration from x equals 0 up to x equals 1. And then we have dz outside. Now let's perform the substitution. Integral from 0 up to 1. Put 1 where there's x, so this will be 1 cubed over 3 plus 1 over 3 times 1 plus z squared times 1. If you substitute 0, it will be 0 all of it. So I would rather leave it at the moment because of space. You can actually prove that this is correct. Maybe I should just say minus 0 here. I should just say minus 0, and then I have dz. If you put 0 there, it will be 0, 0, 0. The whole thing collapses. Simplifying this, we have the integral from 0 up to 1 of 1 over 3 plus 1 over 3 plus z squared dz. Now this is 2/3 integral from 0 up to 1 of 2/3 plus z squared dz. Now this is the same if you distribute integral from 0 up to 1 of 2 over 3 dz plus the integral from 0 up to 1 of z squared dz. This is a constant, take it out. 2 over 3 integral from 0 up to 1 of 1 dz. This one is too close. Let me put it up there. Too low, that one there. Right. 1 dz. Right. So then plus the integral of z squared is actually z cubed over 3. Limits of integration 0 up to 1. This part here is 2/3 of z. Limits of integration from 0 up to 1. All right. Plus this is going to be 1 over 3 put 1 there, it's going to be 1 cubed minus 0 cubed. This part here, it's going to be 2 over 3. Looks familiar, this part here, if you remember. So that's going to be 1 minus 0. You put 1 there and then 0 there. Plus this is 1 times a third is a third. What do we have? Again, 2/3 plus 1 over 3 is actually 3 over 3. The answer is 1 again. So yeah, the order of integration doesn't matter. I want you to start with z and prove that indeed you come up with the same solution here. So Fubini's theorem actually works even for triple integrals as well. All right, I'm going to stop here in this video. We'll definitely come back with many more videos on integration, like I've promised in the previous video. We're still looking at integration techniques, and then we'll come up with applications of integration, like areas bounded between two functions, and also volumes of revolution, or volumes in 3 dimensions. All right, I'll see you next time.